Okay, so today's plan, you should be able to, by the end of class or by the end of the session, determine the sum and the product of the roots from a quadratic equation, and then determine a polynomial equation based upon its roots. These are two very basic things, and again, something you should have seen before. This particular lesson really shouldn't be anything new for you. But in case you have forgotten, or maybe you have had trouble in the past with this, this is a great chance to refresh your memory about it. So what if you're given the roots and yet need the equation instead of the other way around? See, yesterday we talked about how you're given the equation and I want to find the roots or the solutions. Now what if I give you the solutions and I actually want the equation that's going to happen that way? See, that does actually happen. What if I said, okay, this is what I've got. I want to know how did I get there? Or maybe I want to be able to project onto other things. What would happen at this value or this value or this value? See, this allows me to figure out that equation. Again, in this case, here we're looking at the first example. It says, given the roots of the equation, 2 and 6, write the quadratic equation. So it helps, though, to understand what do we already know about the equations that we're dealing with. If I was to go back a few days and look at one of the questions that we had, let me just do this right up here. I have x squared minus 8x plus 15. And I asked you to find the roots to this. You had to sit there and factor it by, again, doing your parentheses. And we already did this question, so I'm not going to take too much of your time about that. But we would get this. And if I had equals 0 and asked you to solve for those roots, you'd get x equals 3 and x equals 5. Is there a way to instead go from these answers to this without having almost like a reverse? Some students actually choose to do that. They say, okay, I have x equals 3. So they, in this case here where you have the 2 and the 6, they might say, okay, x equals 2 and x equals 6. So one option is you could say, all right, I'm going to bring that 2 to the other side, make it equal to 0, bring the 6 to the other side and make that equal to 0, and then multiply them together. Could you do that? Absolutely. You could then take x minus 2 times x minus 6 and figure out when that equals 0, and then go ahead and multiply that through. So you'd have x squared, right? And if I show all my steps, I'd have minus 6x minus 2x plus 12 equals 0. And of course, that simplifies to being x squared minus 8x plus 12 equals 0. A question which we actually did in the previous session. Now, is there another way, though? Is there a relationship between these roots that we have here and this actual problem? If you remember in our steps of factoring, one of the questions to help us determine those numbers, those roots, were what numbers multiply to give us this 15, and what adds at the same time, what would add or subtract to give us that middle term. So then it must be that the sum and the product have something to do with this. That's the whole point. See, they go hand in hand. Somehow we treat them like they're separate entities, but you already have been thinking that way. What multiplies to give you that last number, and then at the same time, what adds or subtracts to give us that middle coefficient. Okay, so what exactly does that mean? Is there something about multiplying these two numbers, 3 times 5, and I would get 15? Do we see that? Absolutely, you see that. Sorry, I hit that. You get that last number, as you would expect, because that was the question we asked ourselves. And then, is there a relationship between the 3 and the 5 and this middle number, 8? Can we add them to get that? Can we subtract them? Is there some signs involved? Well, again, if we added 3 plus 5, so the product here was 15, if we add them together, we get 8. Now, you might say, but wait a minute, that's negative 8. You're right, it is negative. And so we have to remember this one little glitch in the whole thing is that we've got to switch its sign. So what does that look like for our example here when we have our roots that are 2 and 6? We simply have to find what the sum and the product are. In other words, add the two numbers together, multiply the two numbers together, and it presents that equation, x squared. But remember, switch that sign to be negative 8x plus 12 equals 0. And if you were to look, ta-da, they are in fact the same way in a much faster way. Now again, it doesn't seem that necessary when you're looking at numbers like 2 and 6. Because let's be honest, you can add and you can multiply, or you can even reverse the whole process quite simply. But if you were to reverse that process and you're dealing with roots like this, 1 plus 2i and 1 minus 2i, all of a sudden now what you've got is you have x equals 1 plus 2i, and you have x equals 1 minus 2i. And so when I switch the signs of those, that becomes x minus 1 plus 2i, and then you equals 0, and you have, x minus, and again, 1 minus 2i on this side equals 0. And then you would have to multiply those two together, and you could see how that would get quite cumbersome. Or the alternative. The alternative is simply to add them and to multiply them. Now, in case you have forgotten, and this is a great chance for me to kind of refresh your memory, hold on, come on, little dude, is to refresh your memory about I. I'm sure many of you have forgotten about I and would love to never remember I. But this is really as basic as I get. If you remember I, or the imaginary root there, is the square root of negative 1. So therefore, when I would square it, I would get square root of negative 1 times the square root of negative 1. And of course, as you learned previously, when I multiply roots like that by themselves, you get that number. So you would get negative 1, as you'd expect. Now, if I multiply by another square root of negative 1, what happens is this is I, right? That is I. So sometimes you'll see it written as, okay, that's negative 1 times this, so that's what this is. Or you might see it as negative I. It could be written like that. And then if I multiply by another one, that would basically mean that you'd have square root of negative 1, so you'd have this would be negative 1, and negative 1 times a negative 1 makes positive 1. That's where the roots of those come from, and that will help us eventually. So if you don't have that written down already, pause this video, quickly write that down. You definitely need to have that as a resource, maybe even in the front of your binder, so you can easily see what that is. Okay, so now let's go ahead with this next question. Given the roots of the equation are 1 plus 2i and 1 minus 2i, write the quadratic equation. The first thing I'd like you to do right now is to add the two of them together. When you add them together, you get 1 plus 1. Add those two together, you get 2. Plus 2i and minus 2i cancel each other out, so you just get 2. Adding should be very simple when it comes to this. Multiplying, okay, 1 plus 2i and 1 minus 2i. You're going to treat that I similar to the x, actually. Let me extend the page so I can write here below. So I have 1 times 1, which is 1. I would have a minus 2i and a plus 2i. That, of course, cancels each other out. And then I have a plus 2i times a minus 2i makes minus 4i squared. Okay, I squared again is negative 1. And so that really makes 1 plus 4, which is 5. So what do I have? I have a sum of 2. I have a product of 5, which gives me x squared minus 2x, don't forget, plus 5 equals 0. And that's what we get for an answer. I believe if I was to remove those boxes, I'd have the answers underneath there, but this is sufficient. Any questions about this? Great. So now let's look at, okay, so now I have an equation. What's the sum and the product given the equation? This is almost like, this is the easy part of things. So if I was to look at this question, x squared plus 5x plus 6, what's the sum? Remember, the sum is found right here. But remember, we changed its sign. Do you remember that? I hope so. Because if you remember that, then it's quick and easy to say, okay, the sum is negative 5. The product is 6. Let's do another one. Ooh. Okay. Sum, product. What's the sum? What's the middle term? I hope you're all saying 0. And that, I would be very impressed if you were able to do that real quick. Because remember, there's no middle term there. Now, some of you may say, but what about that 4? The 4 isn't the middle term. It's the last one. That is the product. And it isn't just 4, but negative 4. Don't forget that sign. And so that would be our answer to that one. Next one. All right. What's the sum and what's the product? What is the sum? I hope you remembered that negative, because remember the sign switches for the sum. The product, is there anything down here that we're multiplying to be? Nope, there sure isn't. And if you were to look and actually factor that puppy out, it all would make sense. Let's look at the next one. Ooh, a little bit trickier. What happens when the coefficient there is not 1? Because that does throw a wrinkle in this. Now this is kind of an interesting one in that we can actually divide all of this by 2. And so it makes it a little bit simpler because, well, if we factor out that 2 first, then it becomes real obvious what the sum and product are. We would have the sum being 2 and the product being -4. So the next one. Oh, and I guess that's all of them. So there you have it. And that's today's lessons with the sum and the product of the roots. There is some neat little techniques. Sometimes you'll see it like this. I think some of your teachers might have shown you this way of factoring even. And if you saw this way of factoring, it really is the same idea. The product was written on the top, and the sum is written down here. So you're basically saying what multiplies to give you this and what at the same time. But all I want you to do is, hey, can we simply either factor these, that's one option, and factor it, or we could come up with the equation. Because we're dealing with sum and products today, let's just rewrite these as equations. How could I rewrite this as an equation? We have the sum is 3, so that would mean it's going to be x squared minus 3x minus 10 equals 0. How about this one here? Again, the product is -8, and the sum is -7. So when we write that equation, it's x squared plus 7x minus 8 equals 0. All right, a couple more. Next one, what would this one be? Hopefully you did. In fact, remember to change that sign. And if you did, then you would have had the same answer as that, x squared plus 8x plus 15. And then the last one here that you see, come on, scoot down. The last one here that you see, again, if I pull it down, you can see that you should have, again, but I forgot to change that sign, so maybe we don't want to do that. You should have the sum being x squared minus 2x minus 24 equals 0. Okay. Hopefully you don't have any questions, and if you do, please bring them to class tomorrow or the next time that we meet. And I know soon approaching, we will be having our pre-test for this class. So good luck, and we'll see you tomorrow with practice.